We are going to look at the formation of a geminal diol of an aldehyde or a ketone and base. Now, remember from lecture that diols, these hydrates basically, they don't form spontaneously really to any great degree in just plain old water, unless you're dealing with something like formaldehyde. They don't tend to favor this hydrate as much as they do the aldehyde or ketone, even though they are in an equilibrium. Now, if you want to favor that formation of the diol, the geminal diol, or the hydrate, you need to catalyze this process with acid or base. And so we're going to look at the one that you would catalyze with base. And this is still going to form an equilibrium, but this helps you form more of that hydrate by doing so. So you actually do add the acid or the base. Now I'm going to show this with an aldehyde, but be aware that this could be done with a ketone just as easily. So I'm going to make a very random R group. R is just some carbon group, and if you don't want a hydrogen there, make it another R group. The key to knowing to do this is you typically would have some sort of a hydroxide. So it might be something like sodium hydroxide in water. And this is still going to form an equilibrium. But if you have enough of this hydroxide present, it will drive the reaction toward the hydrate rather than keeping it toward the aldehyde. So you have a very strong base here, and solution is the key here. You've got a hydroxide. You do not have an acidic proton. That hydrogen attached to the carbonyl carbon is not acidic at all. And so it is much more likely to undergo nucleophilic substitution. And the carbonyl carbon is semi-positive, so it will add to the carbonyl carbon. And carbon can't have 5 bonds, so you have to break a bond. And the bond that is the easiest to break is the pi bond, since pi bonds are weaker than sigma bonds. And oxygen is the more electronegative of those two elements, so it takes those electrons with it. And you will form an alkoxide ion intermediate. You're going to see chemistry like this over and over and over again. So be aware that this is how you do this. You add a nucleophile, and that's really what the hydroxide is a nucleophile. We're going to do this repeatedly in organic chemistry. So be aware that it could be a variety of different nucleophiles that does this job to make this alkoxide ion intermediate. The only difference would be that the OH group would be some other nucleophile. Now at this point you still have an alkoxide intermediate, and so it's about the same base strength as a hydroxide. That's why this is an equilibrium. You also have some water present based on what we had previously. So water is going to act as your proton donor, and this oxygen will come in here and remove the proton, and you'll give electrons back to the oxygen here. And as this occurs, you'll be able to make the hydrate, or this geminal diol. You can call it either name. And again, you end up with a hydroxide. So you really didn't make a weaker acid-base pair. That's why it's an equilibrium reaction. But this will allow you to make more of the hydrate in solution.